Let's look at a negatively charged particle. So this is a negative charge. And how does the electric field look around it? So we know that we need a measuring device. So our measuring device is a positive test charge. Remember, test charges are always positive. So now what's happening? We have a negative charge, we have a positive test charge. So the positive test charge, our electric field looks like that. It's an attraction because it's a negative positive. So at our measuring device, we see that the arrow is pointing towards the negative charge. So let's put our test charges around here. Let's go here. We see that they are attracting. So our electric field line looks like that. And as you can see a pattern that they are all inward. So if we have a negative charge, our electric field is going to look like this. At a negative charge, the electric field lines are always towards it. So that would be the electric field. So what if we have a positive and a positive charge quite close to each other, that each one is affecting the other one? Now what would our electric field lines look like? So our electric field lines, we know that from positive charges move away from the charge, from each one. But what's going to happen when they come close to the other one? So for this one, it's going to come close, and then it says, well, there's another positive charge and I don't want to go there because we repel. So it's going to go up like that. And as for this one also, it's going to go up. They are never going to cross. Electric field lines never cross. So something that comes out like this would also go down like that. And the ones here will continue. So it will likely look something like this. So this is what an electric field next to two positive charges will look like. And you can draw infinitely number of arrows as you wish. So this is our electric field lines next to. Now what if we have two negative charges? So let's have a negative charge and a negative charge. So as we know, for negative charges, our arrows are inward. So they come like this. But what happens when they are closer? So now if you look at the middle part here, again these are negative charges, so they repel each other. So they look something like this. It's very similar to the positive charges, the two positives, but note the direction of the arrows. Come like this. And so on. Now what we have, a positive and a negative charge. A positive, we have a negative charge. Now from a positive charge it goes out, and in a negative charge it goes in. So whatever the electric field line goes out here can actually go into the negative charge. So it goes out, but they attract because it's positive and negative. So they go like that. The same here. and then on the side here we still have it's coming in, and then from positive charges it goes outward, so these lines go out. So that's what an electric field looks like with a positive and a negative charge. And we can draw infinite number of charges, and the drawings get more complicated. It's not that easy if I just put a positive charge here and then see what happens, or a negative charge here and a positive charge here. It's not that easy to think about it, but things to remember is that the positive charges, the arrows go out, negative charges, the arrows go in, and like charges repel, and positive and negative charges, they attract. So if you go here, you can see like in the middle there are no lines at all, so the electric field here is actually zero. Electric field here is zero because there are no lines.